Here we go, back with part 2, example 3. What if Ferd made monthly payments of $70 into the same account? Would he have enough? So this idea, in 2 years, $70 a month. So 2 years, monthly amounts, that's 24 payments. Account's making 7%. The present value is still zero. And the idea of the payment is $70, and the question is, I want to find out the future value. Is this going to be $1,800? Well, periods a year and compounding periods a year are both 12. Let's figure it out. That 24/7, and then present value 0, but we're making $70 payments. The question is this $1,800? Well, let's solve for it. And he's a little bit short, $70 a month. And notice the $70 out of his pocket, then he gets to take it out of the bank at the end and pay off his gambling debt. Quite the day for Ferd, you know, smoking and gambling, and I wonder what he's up to in the next example. So there, -17, 7 decimal, what was the decimals? 67 cents. So he's going to be just short. He will be, what's that? That's $2.23 short. I imagine he'll be able to make that up rather than get his thumbs broken. Good. Okay, what's next? Using the TVM solver, we can quickly update values to explore the effect of changing characteristics of the annuity. So this idea of you know, I'm making some investment. What happens when I switch just a little bit? So this idea is now Ferd is paying down his credit card. Okay, and this idea is he wants to minimize the amount of money that he's paying on his credit card. Now this is a little bit of a strange question, but we'll get into it. He makes $50 credit card payments for 4 years. And the first question is, if he would have invested the money instead of paying down his credit card, how much would he have had? So if the interest went into an investment rather than back into his account, how would that work out for him? So let's just see. 4 years, monthly, interest rate is 18%, which is actually a pretty cheap credit card, by the way, folks. Check out the rates on credit cards. Usually it's over 20%. The present value, we don't know. The payment is $50 a month, and the future value is what we want to find, right? We want to know how much that he would have if he was putting $50 away rather than paying down his credit card. The payments per year and compounding periods per year is still 12. So let's get the graphing calculator going. 4 times 12, 48 payments. Does that sound right? And then 18%. No value at the starts. $50 credit card payments a month, and we want to know how much he's going to have at the end. So, kind of in total, he's missing out on $3,400. So this was 3478 decimal 26. How much would he would have had? So how much is interest? Notice he's paying these $50 payments every month. You know, how much interest is sort of adding up? Well, remember, the interest is just the end, subtract how much he puts in. Well, at the end it was 3478.26, and the payments were, well, he made 48 payments, so $50. And I put that into a calculator, and I get $1,000. So it feels like, you know, Ferd's being a good, conscientious person by paying down his credit card, but $1,000 of that $3,400 was interest. And of course, we'd love to figure out how to decrease that. Um, One of the ways is to never use a credit card, but we'll talk about if you have to use a credit card. So, for instance, if he has an opportunity to pay more per year, will he pay more or less interest? Assume interest is compounded annually to match the payments. Okay, so notice that, by the way, the $600 a year is the same amount out of Ferd's pocket, right? $50 every month is the same $600. So how many payments, though? Well, it's only one a year. That would only be 4 years, 4 payments, right? The interest rate's still 18%. The payment here is going to be $600. The question is how much is there at the end? Well, one payment a year, compound interest, compounding periods is 1. And so let's change this. Instead of monthly payments, let's have annual payments of more money. $600. And let's see how that works out for Ferd. Well, that was 31.29.26. 31.29.26. It's less money, isn't it? So the interest again is 31.29.26. Subtract the payments, 4 payments of $600, which is $729. Less interest, right? So here, if we think of this, more compounding is more interest. If we think of it that way. Before it was monthly compounding, it ended up with more interest. In this case, it would be less interest because the interest isn't compounding as many times. A third option has him making $25 monthly payments for 8 years. So he's stretching out paying off his credit card over 8 years. Will this save him interest? Well, let's check it out. 8 years. And notice, by the way, that's still the same amount. Twice as long, half as much is still the same amount. 18% interest. The payment's going to be $25 instead, and we want to find this value again. Still 12 and 12. So up here, we're going to have 8 times 12. 8 times 12. 18% interest. The payment's $25, half as much as his original plan, and 12 times a year. Good. And solve for that. 53.20. 52.93. 52.93 even. So again, the interest rate here, 52.93 is, we've got 96 payments of $25. Pound that into a calculator, how much interest this is. Almost $3,000. So it's more interest. So the moral to this little story is longer time frame, more interest. Which is good if you're investing, bad if you're paying back a loan. So if you're trying to pay back a loan, you try and pay it off faster. That's the little moral there. A couple little morals, and that's one of the big themes in our chapter, is to find these little rules about how we save ourselves money and earn our own money and don't have it all end up in a bank somewhere. I think that's it. It is. C'est tout.